Right, in this problem, you're asked to graph the rational function h of x equals a negative 3x minus 12 all over x squared plus 5x plus 4. So the first thing we're going to do is go ahead and factor the numerator and denominator and see if we can simplify this function at all. So let's start there. So we can common factor out a negative 3 from the numerator, and that gives us x plus 4. And then we can factor the denominator to x plus 4 and x plus 1. And so we can see the values that make the denominator 0 would be if x was a negative 4 or if x was a negative 1. Okay, negative 4 or an x cannot equal a negative 1. We're going to come back to those. Those are either asymptotes or wholes. So we'll figure that out. As we see, we can simplify the x plus 4 over x plus 4. That equals 1. So we have our function in simplified form. H of x equals a negative 3 over x plus 1. Okay, so now we can see what we have here in this simplified function. The value that would make the denominator 0 would be if x was a negative 1. So that is going to be one of our asymptotes. So x equals a negative 1 is one of those. And then you can also use what we've done before, which is to look at the degree of the numerator, which in this case is 0 because there's no x value, and the degree of the denominator, which is 1 since this is x to the first power. And if the degree of the numerator is smaller than the degree of the denominator, then your other asymptote is y equals 0. Okay, so that's your horizontal asymptote and your vertical asymptote. Okay, which means that this other value up here that we had before we simplified this restriction right here is a whole. So we're going to go ahead and plot our asymptotes. Okay, so remember, if you're not sure how to do this, you can click on how do I draw a rational function, so you know how to use these tools here. So here we're going to use this tool right here, rational function with horizontal asymptote. So we're going to go ahead and click on that. And so our vertical asymptote was x equals a negative 1. So we just click that there. And now we're going to place our horizontal asymptote. So that was y equals 0. So this is the line y equals 0. Okay. Now it's asking you to plot, place your first point. So let's say, so basically what you want to do is go take this vertical asymptote and pick a value over here on the right of that value. So let's see, that would be when x is 0. So if we replace x with 0 here, we're going to get a negative 3 over 1, which is a negative 3. So when x is 0, y is a negative 3. We plot that point. Okay, and now we want a second point. So we just need to pick another value to the left of this vertical asymptote. So let's plug in a negative 2. So if we replace a negative 2 in this equation right here, we get negative 2 plus 1, which is a negative 1. So a negative 3 divided by a negative 1 is a positive 3. So that means when x is a negative 2, y is a positive 3. We plot that point. We need to add the whole, and the whole is at x equals a negative 4. So we come over, we click on this open point here, we go over to a negative 4, and then we're going to go up until we hit the graph, and then we click that point right there, and it's going to create a little hole for our graph. Alright, so we are going to start off the same way. We're going to factor the numerator and denominator, so I can common factor out a 2 and an x from both of these, and that's going to give me x plus 3. And then I can factor the denominator to x plus 3, x plus 1. And so we can see that x cannot equal a negative 3, because that would make the denominator equal to 0, or a negative 1. Okay, so we're going to simplify this, and then we get the new function for f of x. The simplified form is 2x over x plus 1. Okay. So now we're going to look at this, and we can see here that we still have this asymptote here. X plus 1 is going to be our asymptote. So x equals a negative 1. And then remember that when these powers are the same, we actually take this value 2 over 1. Okay, and you actually do have an asymptote here. It's going to be y equals 2. Okay, and then we can plot these asymptotes, and remember that this is going to be the whole at x equals negative 3. So we're going to have a whole at x equals a negative 3. Okay, so let's go ahead and plot our asymptotes. So x equals a negative 1 and y equals 2. And then we're going to go ahead and place a point to the right of x equals negative 1, so that's 0. So if I replace 0 here, I get 2 times 0, which is 0, over 0 plus 1. So you end up with 0 over 1, which is just 0. So when x is 0, y is 0. Plot that point. Now I'm going to pick the value x is a negative 2 and replace this with a negative 2. So 2 times negative 2 is negative 4. Negative 2 plus 1 is a negative 1. So I have a negative 4 over negative 1, which is a positive 4. So negative 2, positive 4. And then I need to add the whole at x equals a negative 3. So I click this button here, and x is a negative 3, go up and place the whole on that graph. Now every once in a while you might get a problem that looks like this, where you graph the rational function f of x equals negative 4x plus 24 over x minus 6. When you simplify that, you end up with f of x equals a negative 4. Okay, and this is just a horizontal line. Okay, and then so you have the whole here, right, at x equals a positive 6. So you're going to graph the line y equals a negative 4 basically, and then put the whole here. Here's the line. Okay, and if you look at the tools, you're going to see a tool that has a line, and so you can just use that tool to draw this line and then put the whole there.